Hello, it's Keith here, and this is lesson 4 of the Hello World series of my 6009 assembly programming tutorials. Today we're going to be looking at the dragon today. Again, we looked at this once before in the first episode, but this time we're going to be doing the Hello World message a little bit differently. In the original example, we drew characters to the screen by writing bytes to screen memory, and each byte in the text mode was a character of the screen. Now that's fine for the text mode, but if we're going to be using graphics, we're going to need to draw graphics to the screen somehow, and we might need to do characters. So the problem with the dragon is there is, to my knowledge, no internal font that we can use, and no firmware functions. So the only option, and it's actually my preferred option anyway, is to do everything ourselves and to define our own font and then draw the bytes of that font to the screen. That's what we're going to be doing today. You can see here we've got a 4-color mode. This screen is 128 by 192 with 4 colors, and so we're going to take our font and draw it to the screen. Now in my tutorials we always use a 2-color font, just black and white, 1 bit per pixel. So we're going to convert that to the 2-bit per pixel screen, and that's actually beneficial to us in general because that means we can save some memory on our font. And the font we're using is the same one as we use in all of my tutorials, and it's the original one from the Chibi Akuma's game, and you can see it just here in my AkuSprite editor. And I export this from AkuSprite editor and I use this in all of the tutorials. Okay, let's go over to the source code. Let's take a look at the source code for today's example. So here's the code. Now you'll see at the start we've got some definitions here. We've got one called monitor narrow screen, and this is to reconfigure the monitor, the debugging tools, and you can see the results on the monitor here where we're showing the registers and then we're showing a dump of some of the memory. So if you don't want to use that, you don't need this monitor narrow screen function here. It was just to reconfigure the software to use a very narrow screen and basically add some extra page breaks. Then we've got some defined temporary variables. I tend to mimic the Z80 registers here. So we've got a pair BC, and these are made up of C and B here. The name doesn't mean anything. BC is just a pair of 8-bit values that we can use, and we're going to use those in our code to store X and Y values at some points, because we needed some extra memory. Our program starts at C000. Now in this example I'm not going to teach you how to actually compile the example and run it on an emulator. I did that in the original Hello World example, the first one, so if you need to know how to do that, please take a look at that example. What we're going to look at today is just the graphics side. So we start off by loading a stack pointer. 8000 is our stack pointer, and we clear the temporary X and Y position of our cursor. So whenever we draw to the screen we've got a cursor position, and we're going to use those to calculate the memory destination. We're then going to set up our screen, and to do this we need to do a variety of writes to particular memory addresses and also send a value to another memory address. So we're going to see the writes that we need to do here. So what we do here, we're going to be using what's known as P mode 3. This is a good all-round mode, I think, for the dragon. It's got reasonable resolution, reasonable colors, doesn't use too much memory, relatively speaking. So this is the one I decided to use here. And I've made a little game called Suckshoot, which we're going to look at next time, and that's why I needed this font. I needed a font for my graphics mode. So that's what we're using. So here are the settings we need to use for this screen mode. Now these are of course all fixed here, but if you want you can use the alternate graphics modes, and I did do an example in the platform specific series on various other graphics modes, and it should be relatively easy to tweak this example to work on those other screen modes. All you really need to do is change the coordinate calculation, the memory address calculation, and also if you're using the 2-color mode you just need to change the bitmap transfer routine. Now what we've got next in our main program is a test for the monitor, a test for the memdump. You can see here these are pretty straightforward. Monitor just dumps all the registers. Memdump will dump, in this case, 32 bytes from C000 onwards, and you can see that has been done just here. So that's what those are. They're simple testing tools I use in my programming. And then we've got the all-important hello print string message. So hello, the address for the hello is being loaded into the Y register. I use 255 termination in my example, so you can see hello world here. Now the interesting thing is here is we can actually now do upper and lowercase. Before we were using the firmware to do the work for us, and that can only do uppercase. So this is a bit more flexible for us. Okay, so that's what we're going to be using here. We're going to show that print string to the screen. Now, when it comes to print string, all we're doing is we're loading consecutive bytes from the Y register's address, seeing if they're 255, and if they are not, we're just using print char to show them to the screen. the print char routine is going to do all of the work for us. Now the font we're using here, this is the font. If I just zoom this out here, you will see we've got a fairly complete font here. We've got all of the letters of the alphabet in upper and lower case and a variety of symbols. What we don't have though is anything below the space character. Now the space character, if you don't know, is character 32. So we're going to have to subtract 32 at the start of our code to basically offset the ASCII character to the address within our memory. Now what we're going to do next is we're going to shift that and effectively multiply it by 8. And the reason for that is that each of our characters is 8 lines. Each line is a single byte. So we're calculating the offset of our character here, and then we're adding the base, which is the font. Now the font here is being included as a binary file. This is an export of the font, so that's what we're using as our source data. So this is going to be our bitmap data, and then we're going to want to transfer that to the screen. Now what we're going to do is we're going to use the getScreenPos function to calculate the VRAM address that we want to show our character to. Now this is designed to take an XY position with the X position in bytes and the Y position in lines. So what we're going to need to do is we're going to need to convert our cursor X and Y position. Now we've loaded both in one go here by reading a 16-bit value from cursor X. Cursor X is an 8-bit value and cursor Y is immediately following it. So this has effectively loaded the A register with our X position and the B register with our Y position, and then we multiply the X position by 2 by shifting it to the left once, and the Y position by 8 by shifting it to the left 3 times. So this is effectively multiplied these up, and then we're storing the X byte position in B in our 0 page and our Y position in C in our 0 page, and then we're using getScreenPos to calculate the memory address that we want to write to. That's what we're doing here. So we're taking that Y position and we're multiplying it by 32 here, and then we're adding our screen base, which is at memory address 400 here. And then what we're doing next is we're finally adding the X position, which is in bytes, so we don't need to multiply that up, and we're returning this value in Y. So Y is now our screen destination. Now we calculated our font position for our character before, we pushed that into D, but we're popping it back into X here. So we're now in a situation where our Y register is the destination and our X is the source. What we're going to do is we're going to read a byte in from our source, and then we're going to have to move that to the screen. The problem is, of course, that our font source is 1 bit per pixel and our screen is 2 bits per pixel. So we're going to need to take that 1 byte and basically expand it out into 2 bytes. And I've got a function called doFontByte to do that for me. Now what this is doing is it's basically shifting out 4 bits from our source byte, and it's going to expand them out into 8 bits in our destination. Effectively what we're doing is we're taking a nibble and we're splitting out the blitz so that each bit is made up into a pair, and this will effectively set our font to be one of the 4 colors. So that's what we're doing here. A is our destination and B is our source, so we're shifting 1 bit out of B. We're moving it twice into A, shifting another bit out into B, moving it twice into A, and so on. And then we are storing our built-up byte to the screen, that's Y, and then we're incrementing the Y destination. So the first time we do that, we've used half the nibble of our source and we've written 1 byte to our destination screen, and then we do the other half and write it to the screen. So that has effectively done 1 line of 1 character on the screen. So we now get back our Y destination. We then add 32, which effectively moves us down 1 pixel line of the screen. We are then going to repeat until our counter, which is in B, reaches 0, and our counter is of course 8 lines because our font is 8 lines tall. Now when we've done that, what we're going to do is we're going to increment the X cursor, moving us along the screen effectively, and then we are going to restore all our registers and the program counter, which effectively returning us to wherever we came from, which in this case is the print char routine. So that's basically what we've got here. Now, as I say, if you were going to change this and work in a different screen mode, if you were working at high resolution, then what you would want to do is you would want to change this code. If your screen was twice the width, you'd want to change the multiplication here from 32 to 64, and the same here. Now, if you were working in a 2-color mode rather than a 4-color one, well, this would be far easier. You wouldn't need to use this doFontByte. You would just read in a byte from the source and write it straight to the destination. Of course, I could have had my font in 4 colors, and then that code would have been much easier. The problem is the font file would have been twice as big, and so I tend to prefer using a 1 bit per pixel font for the default, and then depending on the game, if I'm doing a game that wants more speed and has a lot of spare memory, then maybe I will do that and use a 4-color font in the native format of the screen. But as I say, the font file is relatively big for the systems that are running, like this is running from a 16K ROM file, so memory isn't exactly abundant. So I prefer in this case to work with a 2-color, a 1 bit per pixel font, and then convert it. So there we go. So you can go to my website, you can download the source code for today's example, and of course the font file and Aquasprite editor, which I use to create this. If you liked what you've seen today, please like and subscribe, and please go ahead and download the code and have some fun with it. If you want to support my content, you can buy my book, Learn Multi-Platform Assembly with Chibi. I'm afraid it doesn't cover 6809. It covers Z86, 502, 68000, 86 and ARM, but I will make another book which will cover 6809 because the first book has indeed been a success. I also have to say a big thank you to all my patrons you can see scrolling over there, and hopefully you're going to like and subscribe, and especially subscribe, because the next time I'm going to be doing a video on the Dragon. We're going to be covering my little suck shoot game, which is a very simple duck hunt type game where you have to shoot enemy bats on the screen. Very simple game, and it only took me 2 days to write, but nice simple little example, and hopefully you'll have some fun with it. Anyway, thanks for watching today, and goodbye.